Okay, dear students, we are going to solve our next numerical example of chapter 6, which is 6.2. The statement of the numerical example is as a water hose with an internal diameter of 20 millimeter at the outlet discharges 30 kg of water in 60 seconds. Calculate the water speed at the outlet. Assume the density of water is 1000 kg per meter cube and its flow is steady. Okay, solution, students, the solution of this numerical can be as we have given that mass, flow per speed. This is the given data in our numerical example, which is 30 kg per 60 second. So when we divide this, we can have a 0.5 kgs per second. Now cross sectional area, we know that diameter is given, that cross sectional area is cross section area. We can write as A cross sectional area, which is equal pi r square. So this is the cross sectional area of the water hose or water pipe. So student, we know that formula. We can find out the formula. Formula is that to solve this. Okay, what will we have to find? We will have to find out the speed. This is V. So formula can be written as the mass of water discharging per second through area A So this is the through area A, which can be written as, this is the formula, the mass of water discharging per second through an area is given as, we can use this as a density into A into V equal mass per second. We will have to find out the velocity, so we can write this formula as V equals mass per second and divided the term, this term rho, and area will divide by mass per second. So students, we will use this formula after substituting the values. Mass per second we have been derived here. This is 0.5 kg per second. Rho is 1000 and the area should be pi r square. So here we can write this as, okay, another thing which is given as in your numerical problem, its diameter is 20, diameter is given as diameter 20 millimeter and the radius should be half of the diameter, so 20 divided by 2, which is 10 millimeter is the radius. Okay students, we can find the 10 radius as meter. We will divide 10 by 1000, then we can have 10 into 10 raised to power minus 3 meter. So this is the radius, and here we will write the value of radius. 1000 is the density, pi is 3.14 and the radius can be written as 10 into 10 raised to power minus 3 meter. So by solving this ratio, we will have What? When we solve this ratio, students, we will have 1.6 meter per second. So this is the speed of the flow of water, discharging water through a hose pipe. How can we find out this? We will use this formula rho into A into V, and which is equal mass per second, and we already have derived out mass per second is 0.5 kg, and by rearranging this we can have the value of the V equal mass per second over rho into area, and area is as pi r square. We have given diameter 20 millimeter. First we will find out the radius. How can we find out the radius? First we will divide this 20 millimeter by 2, then we can have the radius, and then we convert this millimeter into meter, and for this sake we will divide 10 by 1000, and we can have 10 into 10 raised to the power minus 3 meter. After that we will substitute the values of all the variables. In this formula, pi we can write as 22 by 7, or we can write as 3.14, and the radius 10 is 10 to the minus 3, and density of water is 1000, and mass per second, which is flow of water per second, is 0.5, and after substituting and calculating values we can have speed of water as 1.6 meter per second. So this is second numerical example of the chapter 6.